Welcome to today's Ground School Explainer. I am absolutely thrilled to be your instructor today as we dive into one of the most critical, yet kind of misunderstood components of your aircraft. We're talking landing gear systems. Whether you are prepping for a check ride or just really want to deepen your aviation knowledge, my goal here is to give you a thorough, totally intuitive understanding of exactly what's happening underneath you, from the tarmac to touchdown. Let's get right into it. So think about this for a second. What is the principal support of the airplane when it's parked, taxiing, taking off, or landing? It's a simple question, right? But it's literally the foundation of our briefing today. I mean, an airplane is born to fly, sure, but it spends a tremendous amount of its life right on the ground. The landing gear is that principal support. It is your physical connection to the earth, absorbing immense forces and keeping that expensive propeller safely away from the pavement. Here is our flight plan for today. First, landing gear fundamentals. Second, retractable and hydraulic systems. Third, inside the hydraulic flow. Fourth, cockpit warnings and safeties. Fifth, operating speeds and procedures. And finally, number 6, handling landing gear emergencies. Okay, Section 1, landing gear fundamentals. Let's start with the walk-around. First up, let's look at the 2 primary wheel arrangements you'll encounter. Tricycle gear, the one with the nose wheel, is incredibly common. Why? Because it naturally prevents ground looping. That's a dangerous, uncontrolled spin on the runway, and we definitely want to avoid that. It works because the center of gravity is forward of the main wheels, naturally pulling the plane straight ahead. Plus, it gives you awesome forward visibility. On the flip side, we have conventional, or tailwheel gear. This setup is fantastic for rough, unimproved fields because the nose is pitched way up, keeping the prop clear of rocks and debris. The catch? The center of gravity is behind the main wheels, making it way more prone to that dreaded ground loop. And your forward visibility on the ground is heavily restricted. Next, let's compare fixed gear versus retractable gear. Think of a Cessna 172. It has fixed gear. It's simple, requires very low maintenance, and hey, you never have to remember to put it down. But it just hangs out there in the wind, creating massive parasite drag that really eats into your climb and cruise speeds. Enter the Piper Arrow with retractable gear. By tucking those wheels away, you drastically reduce that parasite drag. Boom, higher cruising speed and much better climb performance. But as with everything in aviation, that performance comes at a cost. We're talking more expensive maintenance and a strict requirement for precise operating procedures. Moving on to Section 2, retractable and hydraulic systems. Let's look under the hood. To really grasp this system, you first need to understand the medium doing all the heavy lifting, hydraulic fluid. The core difference between air and fluid is absolutely crucial here. Air is compressible. If you squeeze a balloon filled with air, it just shrinks, right? But hydraulic fluid, it is uncompressible. It literally cannot be squeezed into a smaller area. Because of this amazing property, when our pump applies even a small amount of pressure to the fluid, that immense mechanical force is transferred instantly and powerfully through tight little lines to push the heavy gear up or down. It's kind of like a liquid crowbar. All right, Section 3, inside the hydraulic flow. Let's trace the path. Let's talk about the beating heart of the Piper Arrow's landing gear, mapped out in its hydraulic schematic. The superstar component here is the electrically powered reversible pump. When you move that gear handle, electricity wakes up this pump. Depending on whether you select it up or down, the pump physically changes the direction of the fluid flow, pushing it to either the upper or lower portions of the hydraulic cylinders attached to each wheel to get them moving. So how does this fluid flow actually translate into action? Well, it takes about 7 seconds to complete a full cycle. When you retract the gear, fluid pushes the pistons up. The pump just keeps building pressure until a pressure switch senses exactly 1800 psi. And then, click, it shuts off. That 1,800 pounds per square inch of hydraulic pressure is what physically holds the gear up tight in the belly of the plane. Now, when you extend the gear, the pump reverses, releasing all that pressure and pushing down. But to stay down safely, the system doesn't rely on fluid. It relies on physical mechanical locking. We're talking heavy springs, good old-fashioned gravity, and over-centered J-locks. These are heavy, hook-like mechanical latches that secure the gear safely into place. Once it's down, it is locked down. Which brings us to Section 4, cockpit warnings and safeties. It's all about situational awareness. In the cockpit, you have some seriously crucial annunciators and warning horns. Your primary goal, every single time, is to see those magical 3 green lights. That means all 3 down limit switches are physically engaged and the gear is locked. During that 7-second transition, or if the gear isn't fully locked for some reason, you'll see an unsafe red light. But what if you just forget? It happens.
Task saturation and distractions from the tower absolutely cause gear-up landings. To save you from this expensive mistake, a really loud warning horn will sound if your throttle drops below roughly 14 inches of manifold pressure. Basically, the plane knows you've pulled the power back to land. The horn will also scream at you if you drop your flaps past 10 degrees while the gear is still tucked up.
Now, you might be wondering, what prevents you from accidentally bumping the gear handle up while you're just sitting parked on the tarmac? That would be the brilliantly simple squat switch, located right on the left main gear. On the ground, the sheer weight of the airplane compresses the oleo strut. That's the gear's main shock absorber. This keeps the switch open, totally cutting electricity to the hydraulic pump. On takeoff, as that strut extends to its full length, the switch closes, completes the circuit, and finally gives you the power to retract the gear. It's an absolute lifesaver. Let's move to Section 5, Operating Speeds and Procedures. Let's talk limits. We need to talk about your V-speeds. You can fly with the Velocity Landing Gear Extended, or VLE, up to 129 knots. You can also lower the gear, known as VLO extension, below 129 knots. But notice that maximum retraction speed is heavily restricted to just 107 knots. Why such a big difference? It's all about the nose gear. When you retract the gear, that nose wheel has to physically fold forward directly into the massive dynamic force of the oncoming relative wind. If you are flying faster than 107 knots, that wind pressure can overstress and severely damage the delicate internal components of the nose gear system. Because of these strict limitations, standard operating procedures dictate our exact timing. On takeoff, please do not just blindly reach for the gear the very second your wheels leave the ground. You want to delay retraction until you show a positive rate of climb on your VSI, and you have officially run out of usable runway beneath you. Why wait? Because if you have a sudden engine emergency in those first few critical seconds, you absolutely want your gear already down and locked to absorb the impact. Now for Section 6, Handling Landing Gear Emergencies. Time for some scenario training. Imagine this scenario. You are on approach, you throw the gear lever down, but you don't get your 3 green lights. Instead, that unsafe red light is staring right at you. What is your very first step? First, and most importantly, stay calm. Execute a go-around and climb to a safe altitude well outside the airport's busy airspace. Give yourself the time and the altitude to troubleshoot safely. Then, simply recycle the gear, retract it, and extend it exactly 1 time.
If it still doesn't lock after that, we run the checklist flow. Master switch on. Ensure the alternator is on. Check if the pump circuit breaker popped from a sudden overload. If it did, you can reset it, but only once. Next, check your ammeter. If it shows a heavy electrical load, it means the pump is actually trying to work. Oh, and here is a brilliantly subtle trap that catches a lot of pilots. Check your nav lights. If your nav lights are on, the gear indicator bulbs automatically dim for night flying so they don't blind you. In the bright daytime, you must turn the nav lights off to get full intensity on your gear lights. You might actually be perfectly down and locked, but just completely unable to see the dim green bulb in the sunlight.
Now, if you've tried all of that and it's mechanically stuck, it is time for the emergency freefall extension. First, reduce your airspeed below 87 knots to minimize wind resistance. Leave the gear lever in the down position so the pump doesn't try to fight you. Then, you pull the emergency extension lever. This physical action opens a valve connecting the high and low pressure hydraulic lines, completely releasing that 1800 psi of pressure holding the gear up. Gravity and heavy springs will abruptly pull the gear down into the locked position. All right, new scenario. You are in steady cruise flight and you experience a partial loss of hydraulic pressure. Since there's no actual hydraulic pressure gauge on the panel, how do you even know it's happening? You'll know by closely watching your ammeter. Remember, the gear is held up by exactly 1800 psi. If a tiny leak causes the pressure to drop by about 300 psi, the pressure switch automatically kicks the pump back on to repressurize the system. So you will literally see the ammeter needle periodically rise and fall as the pump cycles on and off, desperately fighting the leak. Scenario 3. Despite your absolute best troubleshooting efforts, you have to land asymmetrically. The right main gear is down and locked, but the left main is totally stuck up. What do? First things first, burn off as much fuel as possible to lighten the aircraft and drastically reduce your fire risk. When you finally land, you must touch down gently on the good gear first. Keep that good gear into the wind if possible and use opposite aileron, so in this case, right aileron, to keep that left wing off the pavement for as long as you possibly can while you bleed off speed. We've covered a massive amount of technical and operational data today, from hydraulic principles all the way to emergency free falls. But if you take away only one single thing from this ground school explainer to keep you safe out there in the traffic pattern, let it be this undeniable aviation golden rule: gear is always first, then flaps. Commit that simple phrase to memory, respect your airspeed limits, and you will absolutely master the complex systems beneath your feet. But let me leave you with this final thought. The next time you reach for that gear handle and hear that heavy, satisfying mechanical thump beneath the floorboards, ask yourself, are you simply trusting the airplane to do its job, or are you truly in command of it? Thanks for joining this explainer, and stay safe out there.